Hey folks, I want to let you know about the sponsor of today's episode, Stream. Stream powers chat messaging activity feeds for billions of global end users across thousands of different apps. So if you want to do anything with chat or feeds, then you definitely want to take a look at Stream and their awesome SDK. They have SDKs not only for iOS, but Android as well as React, Unreal, Angular, Unity, Flutter, and more. They obsess over their API and its ease of use for its customers and provide awesome tutorials for their developer teams. So if you're looking at adding any sort of messaging to your app, Stream and Stream Chat is going to be the easiest way to do it in your iOS app. They provide all sorts of high-level UI components to connect Stream Chat API with minimal coding. If you're on iOS, they have both SDKs and Swift packages available for UIKit as well as SwiftUI. Go ahead and click on the link in the show notes below to try Stream Chat for free for 30 days, or apply for your Maker account, free forever, or qualifying teams. If you're looking at adding any sort of messaging or activity feeds to your app, then Stream is definitely the way you're going to want to go. Accelerate your launch, focus on your app rather than having to worry about all sorts of problems with networking and messaging and social feeds, and grow your app. Stream is trusted by thousands of companies, more than 1 billion end users to reliably scale, regardless of demand. Go ahead and click on the link in the show notes below to give Stream a try today. Thank you, Stream, for sponsoring today's episode. Welcome to another episode of Empower Apps. I'm your host, Leo Dan. Today, I am joined by Aviel Gross. Aviel, thank you so much for coming on.
Yeah, thank you for inviting me. I'm very excited to be here.
I'll let you go ahead and start by introducing yourself.
Yeah, so I am working currently at Adobe, working on the Behance app for iOS. And Behance, for those who don't know, it's some weird combination between a social network for designers and digital artists, and also a portfolio for professional designers, professional artists. There's also live streams. We also have jobs now for designers. So it's kind of like an ecosystem for professional designers or amateur photographers or anyone who's into anything creative, actually.
So when you were joined the Adobe team and started working on Behance, we'll be talking about SwiftUI quite a bit today. What was the situation like as far as like SwiftUI and moving over from UIKit?
Yeah, so I came actually from Facebook before I worked at Adobe. I was at Facebook working on the what's called the Blue app, which is the main Facebook app, on the infra team, and it was a whole different experience, So Facebook has insane scale for the app and for the amount of engineers working on the app, and so I got very used to that structure and UI where everything is completely different, not like Apple is doing it. It was using Component Kit, which is open source, but as far as I know, Facebook is by far the biggest user of that UI framework. And Component Kit is actually interesting because Component Kit is a declarative UI framework that has been around since, I think, 2014, if I remember correctly. That is when Facebook introduced it. And it actually implements a lot of the ideas that SwiftUI brings. So I was used to that, which is sort of this declarative style in Component Kit. And then I joined Adobe, and at Behance, there was none of that. It was completely, a vanilla Apple iOS design patterns and technologies. It was UIKit and auto layout, all in Swift. Not using storyboards, thankfully, all written in code, and that's how I joined. They also used routers from the Viper architecture, which was an interesting choice because I never actually got to work with routers, and that actually became also interesting later when we started moving to SwiftUI, because from my experience, routers and SwiftUI don't like each other. They don't communicate very well.
So as you've been working on this Behance app for Adobe. What's kind of been the process like as far as migrating from UIKit to SwiftUI?
Yeah, so when I joined, the app was completely UIKit, zero SwiftUI in the app. We also supported iOS 13 when I joined, which in my opinion is not iOS 13 in my opinion is not ready for SwiftUI for prime time.
Yeah.
And then as we moved to iOS 14 and we started thinking about SwiftUI, and the team was excited to try it out and to use it. Like I'm guessing the same with other teams. The first thought we had was, let's pick a tiny button or some small component, or a specific very independent piece of the UI, and write that in SwiftUI and see how that goes. See it in production, see that it doesn't break our build, see that it's stable enough, and kind of move from there. And we did that. We wrote, if I remember correctly, I think it was the follow buttons, just literally the button that lets you follow a user, which we use in many places in the app, which is almost too small, actually. But it kind of gave us the hello world and the ability to say, okay, we have SwiftUI on the App Store running in production. It works. Apple didn't lie to us. And then it also kind of gave us a good opportunity to try to see how the integration between UIKit and SwiftUI works, because obviously we had to use those APIs from Apple to let you combine SwiftUI and UIKit within the same screen. So once we got that, we had a very big rewrite project where we decided to redo the entire feed. The main feed of the app, which is basically the main screen as you open the app. That was a huge project. Just designing it took a few months. And when we started thinking about how we are going to build that project, I kind of came up and said, well, should we think about maybe doing it in SwiftUI? And the initial thought was a cautious maybe, which made sense because, first of all, none of us had a lot of experience with SwiftUI. And so there was no one at the team that could say, yes, this is possible with SwiftUI. And I don't know how many people saw the Behance app or saw the new design, but the new design was much more fluid. The animations were much more complicated than the original design. The original design was very basic in the sense of there's a feed of projects. You tap on a project, we are showing a model view controller where we show the content of that project. And you can just scroll through the images or embed videos or whatever is the content of the project. In the new design, you see the content within the feed. And then when you tap, there is this expand and collapse animation, and the content doesn't move. And it's kind of like a scroll view inside a scroll view. And we hide the tab bar, and instead of the tab bar, we're showing something else. But then when you close the project, we show the tab bar again. It's a very complicated UI, and no one was there to basically say like, okay, I know this is doable. And so what we decided to do, actually, we decided to prototype that screen in both technologies. And that was for two things. And now I'm getting to the performance question you had. Basically, I wrote a prototype for the original, kind of what I thought is going to be the main challenges, which is mostly showing a ton of images right when the app launches, without slowing down the app, and this concept of scroll view inside scroll view. So if you can imagine the new design kind of like TikTok, but where every single project, instead of a single video, it might be a list of anywhere between 5 to 100 images where you can scroll inside them. And so each item in the feed is another scroll view that you can scroll inside, essentially. So you end up creating this scroll view where every cell is another scroll view. That you can probably imagine how that can become pretty heavy on the device pretty fast, especially when that scroll view, and that scroll view is showing images, native video players, like AV players, and HTML embeds. Those are maybe the three most heavy kind of views you can show in an app, and you show dozens of them at once. And so basically, I wanted to know, first of all, is this even doable in SwiftUI? And second of all, will the performance be good enough for us? And so I built the prototype in both technologies, in UIKit and in SwiftUI. There's actually a Medium article I wrote about that process.
We'll put the link in the show notes.
Yeah, and basically, so first of all, in terms of time to write that, it took me about the same. I think it took me like 3 days for each one of those prototypes. Probably a lot of that was my lack of experience with SwiftUI back then. But the biggest thing I saw was, so first of all, it worked in both prototypes. It worked pretty well. Performance was about the same. Both of them look great. But the biggest thing I saw, the biggest difference I saw between the two prototypes was the fact that in the UIKit app or the prototype, so I had a collection view or a table view, I don't even remember, and the delegate and data source and all of that things, and I used diffable data source to try to make it nicer. But even though when I saw the prototype and I try to think, okay, we need to take this prototype and now we need to add a follow button, for example, or we need to add a button to appreciate the project, or we need to add handling opening a project. All those events, all those changes to the UI, for each one of those changes, I realized I need to now think for a second, okay, where does this go in the code base? Where, at which event? So that's kind of like when I realized UIKit is all about events, and you decide where in which event your code goes. So your code might go in layout subviews, or your code might go in view did appear, or view did load, or it might go in sell for row, or hide for sale, or did tap, blah blah blah. And in each one of those events, you need to decide, okay, I now need to take care of everything that needs to change due to that event. And so there's like kind of like two challenges here. One, you need to think where everything goes in, at which event or at which scenario in the usage of the app. And two, you need to think of all the edge cases and all the, all the things that need to change when that event occurs. Or like if you change the whatever the image in that cell, but you forget to also change it over there, or you forget to also update this previous cell or something in the navigation stack, you might end up with in cases where things are not in sync. And then I realized in SwiftUI, I don't care about any of that. None of that matters. And everything I wanted to add was just very clear to me. An appreciate button. It's very clear. I just put the appreciate button here and I'm done. I just build UI and I just check whatever I want to check in the state, and I don't care when it changes, or I don't care which events cause it to change. I just change it when I need, and then I just build my UI based on that. And I think that was the main thing that caused me to say we should go with SwiftUI here.
Right.
Specifically because in that screen, in that feed, we had so many things that need to change other things without even knowing that they exist. And SwiftUI was just a perfect fit for that. And then a year later, we
Well, I was just going to say, like, speaking a year later, like, it seems to me like the big advantage is maintenance of the app. Because there's like a lot of pieces, moving parts when it comes to UIKit that can make it really difficult in the long term to maintain the app. Whereas with SwiftUI, you don't need to do a lot of that hand holding, which is really nice.
Exactly. And I actually see it now when I'm working on the app. So now we're at a point where so that new feed is now 50-50 A/B test. It's launched to 50% of the users as of today, and so now I'm not working on it full time. I'm half working on either fixing things or adjusting things in that code base, while also doing tweaks in the rest of the app, which is still UIKit. And I keep seeing how with UIKit, every time I need to change something, every time I need to fix a bug in the UI or figure something out, like you said, there's so much boilerplate in the UIKit code base because it needs to handle all of those cases explicitly. It needs to take care of everything. If you made that button hidden and you forgot to unmake it hidden somewhere else, then it's going to stay hidden, and now you have a bug and the button doesn't appear. In SwiftUI, you don't care. And when I need to fix something in the new feed screen in SwiftUI, I can see how I don't need to care about those things. Some button maybe needs to be hidden. I check the state. It's either hidden or not, and I'm done. I don't need to care, what happens to it, or when it's hidden, or when it changes, or all that, basically. And yeah, it makes maintenance much easier.
Like, it seems to me SwiftUI, the way it draws the view on the screen is much different than how UIKit does it with like the imperative method. Kind of, if you could explain like in a little bit of detail what exactly is going on with the view in SwiftUI and how it knows when to change, as opposed to with UIKit where it does it based on events and where you have to do it manually.
Yeah. So I think the biggest difference here, which is also something we have to keep in mind when we're working with SwiftUI, is the fact that, and I think a lot of the confusion comes from the fact that in UIKit it's called UI view, and in SwiftUI it's called just view, and that probably causes a lot of confusion. Those things are so different, and people might not realize just how much they're different, even in what they are. So a UI view is an object. It is the life cycle of that view it has a long life cycle. It stays in memory. It is retained. I can keep a reference to it if I want to use it later, which makes sense. I can retain it myself to make sure I keep it. I can pass events to it. It's an object that stays for a while, basically. A SwiftUI view not only doesn't stay, you can't even look at it. I mean, it's not an object, it's a struct, but even if it was a class, you cannot even talk about it like an object. You cannot even talk about it like something that exists in the app. I think a more accurate definition for a SwiftUI view would be even a protocol, or kind of like a custom protocol. It's more, I kind of call it like a blueprint, essentially. Basically, when you create a SwiftUI view, you don't say I have this entity that might exist in the app. You say I have these instructions that tell SwiftUI, this is how you are presenting whatever this content or this piece of the UI is based on that piece of the state, basically. So all you give SwiftUI when you create a view is maybe like a receipt, kind of like how to make a cookie. So it's the same. This is how you present this piece of the content, this piece of the UI, and that's it.
It's almost a function, really. Like that's all
Yes.
it is.
Yeah.
It's like it's just running some code, and like your view builder is essentially a function where it just builds the view, and it's just running that pretty much. Well, we can get into how often that is run, but it's pretty much run every time it draws on the screen or redraws on the screen.
Exactly, and it actually even more than that. So in certain cases, SwiftUI will call the body of the same view more than once for a single render, just for layout. There might be more than one pass, especially if you're doing things like geometry reader or using more complicated UI. SwiftUI might need to call your body multiple times just for rendering a single frame. And so that basically happens all the time. A classic example is if you are adding, there's, I don't know if you've seen that, but there is kind of like a fancy way to track the scroll offset of a scroll view in SwiftUI. I forget exactly how it works, but you basically do a geometry reader outside the scroll view, I think, and then another geometry reader inside on the content itself, and then there's like a way you communicate between them. It's basically a way to track, what's the offset of the scroll view. If you do that, and it works pretty well, people use that method. If you do that, basically every pixel you scroll or every point you scroll, your body is going to be recreated. And so if you print, there's this method that's called the _print changes, which is super useful. I think people should just use it almost always before they, whenever they build heavy UIs, just to make sure things look the way you look, because many times they don't. So it basically
What
tells
is it called again?
underscore print changes.
Oh, okay. Okay.
So usually Apple uses underscore for private APIs or for things that are still experimental in Swift.
Right.
This one is a weird thing because it has the underscore, but Apple in multiple cases, I think maybe even in WWDC talks, Apple already said, this is a thing, you should use it, it's great. So it's pretty official
Okay.
as far as something that's not official can go.
Even though it has the underscore in it.
Exactly.
All right.
Yeah. And I think that underscore, I'm not sure if you get autocomplete or not in Xcode, which is kind of annoying. But yeah, underscore print changes. And you put it inside your body. It's a static method. So you have to do, capital S self dot underscore print changes. And then you will get a print every single time your body is called for that view. And it even prints why that body was called, which piece of the state or which property in the view was changed that caused that
Oh,
body to be
wow.
called again.
That's really convenient.
It's super convenient, and it's usually very surprising. Usually you think, you might put it on some view and then change a view that you think is completely unrelated, and then suddenly you see, wait, why is this called right here? It's when people see things they don't expect in SwiftUI, that's usually what I say is this is probably the first thing you should try. Just put a print changes in there, see what's happening, see if it happens the way you expect it to happen.
So is that the thing that's going to cause the biggest pain when it comes to performance, is how often it's calling the body of a view?
So there are two things. One is how often your view is created and your body is called, and the other thing is how complicated it is to call that body method and all that computed property.
What defines that complexity then?
So basically, the body, because it's called so many times, also Apple keeps saying all the time, again, I think it's also in some WWDC video, when they say the body should be as fast and as, they also say a pure function, which essentially means it should have zero side effects. And those side effects also, that's also for not just for performance, but for behavior.
Like immutable, essentially?
And not in the sense of immutable, but in the sense of so the idea of the pure function is that if your view has a certain state or dependencies or properties in it, and you call body, every time you call body, you should end up with exactly the same thing.
Okay. And
your body should never be different. So you should never have side effects inside the body, basically. And the body should be, like we said earlier, the body should be a pure function of the state. So it means that you should always get the same thing, and it should be fast, because it can be called so many times, probably again more than you expect. And so that's one, your body should be super fast, and the other thing is that you should avoid having it called redundantly. And so that's another interesting example, and interesting difference actually between component kit, what I said earlier that Facebook is using. So if you notice in SwiftUI, there are kind of two steps. So the first step is you create a view, but if you just create a view, if you think about it, you didn't call body yet. So all you have is that struct that is your view with whatever properties you gave it, right? Body is not called. In component kit, the Facebook framework, they do it differently. Inside init, you create the body of that view. And so there is no way to create a component in component kit without also basically providing the body of that component. The benefit in SwiftUI approach is that you can first create the view, and because of that assumption of SwiftUI, which is that your body is a pure function, they sometimes compare the views. If there's a new view and an old view, they might compare the view and decide to not even call the body. If the dependencies, if the properties on the new view are the same as the properties and the state the view that's currently on screen, SwiftUI is going to skip calling the body completely, and body will never be called in the new view. And that's a very critical performance optimization of SwiftUI, where the framework can basically decide to optimize calling the body based on the assumption that you do not have any side effects in your body. And that's why it's so important to not have side effects also.
So I wanted to ask then, how does SwiftUI define those changes? Like, how does it know that something has actually changed within a view?
So basically, let's imagine we have some view tree on the screen. It might be a list and some text and images and blah blah blah. And then maybe the string we have some binding or some state, which is the string for one of the text labels. That string changed from wherever the source is, the data doesn't matter where. Somehow it changed. SwiftUI will create a new view of whatever the view that is using that property that changed, and then it will compare the two, the existing view that's on screen and the new view. And there are 3 ways to do that. And this is kind of where we get into SwiftUI under the hood and kind of like the meaty part of how it works in the low level side of things. So basically, at that moment in time, SwiftUI can either use something called memcompare, which is a low level C function that basically compares the bits of the two structs, of the new view and the old view. And if it decides that they are the same, basically the same memory, at that point in time, SwiftUI will just say, okay, I'm done here. I don't need to call body. I don't need to use the new view. The new view is gone. And whatever was on screen stays as is. If it cannot use memcompare for whatever reason, and we can get later to what are those reasons, it can use double equals, custom equality, if you implemented that and if you ask for it, basically. And if you didn't implement custom equality, then the third option, which is also the slowest way to compare the two views, is reflection, which is, I'm not sure exactly, like the technical details of how it works, because that's, private for the SwiftUI framework, but essentially it's doing dynamic reflection on all the properties in your view to try to figure out if the view is different or not. Only after it's doing that check, whichever method it decided to use, only if it decided, okay, those views are actually different, the state actually changed in between those views, and I don't have the same view, only then it will call body. And then even after it calls body, it does not mean that the body that it's called is actually going to be rendered on the screen. It will then also compare the two bodies, actually.
Okay.
And only if the bodies are different, only then SwiftUI will say, okay, I need to render the new view, basically.
Because you could change the state, but you aren't necessarily changing what's drawn on the screen.
Exactly. You might change the state that the body doesn't care about, or for whatever reason, it doesn't affect the result of the body. Yes.
Right. So going back, out of those 3 options, the memcompare, equality, and reflection, you said reflection's the slowest. Which is the fastest?
So the fastest is memcompare.
Okay.
Because it's literally just comparing the bits in memory. There is no guarantee that you won't have false positive or false negative or whatever. Basically, the idea is that as far as we know, because it's not official, there's no official documentation from Apple. It could be that memcompare fails. And it looks like it's not the same views, but for whatever reason, Apple or the framework decide to do one thing, or the opposite, that they are the same, and the framework decides to also use reflection. But for the most part, what happens is that if the views can use memcompare, and they end up the same memory, that's where the process stops. Basically, that's where SwiftUI decides, okay, I don't need to do anything anymore. And that's usually what we should aim for. That's because that's the fastest route we can go.
And so how can we make sure that our state can utilize memcompare?
Yeah, so
Are there
basically,
specific things we could do?
yes. So this kind of goes into this idea of POD views. So POD stands for plain old data. I don't think it's anything special for SwiftUI, but SwiftUI is using that term to describe views that are basically plain old data, that are simple enough that we can assume that we can just compare the memory and we're not going to miss anything in that view. And so POD views are views that have only simple properties, maybe an int and a string that it takes from the parent view, and that's about it. Once you start having state object, environment object, bindings, all of those complicated dependencies in state, your view is probably not going to be POD anymore. And because it's, my explanation is kind of vague, and it's vague because, again, there is no official documentation about that, but there is another underscore function you can use to check if your view is POD or not. And that function is literally called underscore is POD. And so is in lowercase, POD in uppercase, and you can, again, the same as print changes, you can just put it inside your view, and you will just get true or false if your view is POD or not. So if your view is POD, SwiftUI will use memcompare. If your view is not POD, SwiftUI will use reflection. And then there is kind of like the thing in the middle, which is the double equals. And that's where it starts to be confusing. So basically, if the view is POD and SwiftUI was going to use memcompare, which is the fastest way, and you implement equality, it will be ignored. So if you provide a custom double equal function, but the view is a POD, basically SwiftUI is kind of saying, I don't understand why we don't need that, basically. Like SwiftUI is essentially saying, this is useless, this is redundant, I can do a faster way, which is memcompare. I don't need your equality. And it's ignored. The only way to force your custom equality, for whatever reason, you have your reasons and you need to use custom equality, you can wrap your view in equatable view. And that's actually why equatable view exists, to force SwiftUI to use the custom equality. On the other end, if it's not a POD, the default is reflection. And then if you do implement equality, double equals on your view, then SwiftUI is saying, oh, thank you for providing me this better option. I'm going to use that instead of reflection because this is faster for me. And I mean, faster is, faster is assuming that you implemented the custom equality in a good way. Otherwise, if you do some clown stuff inside your double equals, then that's on you. But in that case, if you wrap your view in equatable view, that wrapping is redundant. As far as I know, it doesn't have any, it doesn't matter if you do that. But it's basically redundant because you don't need that, because SwiftUI has already been like, okay, thank you so much for this double equals. It's much better than the reflection I was going to do. I'm going to use that.
So I didn't get a chance to read your tweets from a few days ago or a couple of weeks ago, but one of the things that I was just thinking about was like you come across as like being strongly for using structs instead of classes for your observed object, since structs are by their very nature kind of PODs most of the time. Is that correct?
Yes and no. So I think usually I try to be cautious on recommending anything in general, or saying that anything should always be happening one way or another. That also goes to there's all this conversation around architecture, and with UIKit, Apple kind of told us you should use MVC and delegates, and that's the way you should do it, and that's it. And then with SwiftUI, the SwiftUI team pretty much took 180 degrees turn and said, you can use whatever you want. We actually worked very hard on making an API that works in every architecture, and so it's on you to pick the architecture that makes sense for your app. And I personally think it's amazing, but also it confuses people because people are now like, okay, what do I do? Do I use Viper? Do I use MVVM? Do I use I don't know,
reactive,
whatever, RX something?
Yeah.
And my view on that is that people need to be careful with trying to find the kind of like the one true thing or the one way to do things. I mean, MVVM is kind of turning out to be the default architecture for SwiftUI. We don't use MVVM in Behance, and I think MVVM can be great for certain teams or certain apps and projects. But I think you also need to be careful of assuming, MVVM is the way to go, and every single project with SwiftUI has to use MVVM. I don't think that's the case. And I don't think it's the case with any other architecture. And so going back to what you said about struct and classes, structs are usually simpler for both the compiler, for memory management, for avoiding things like race conditions and all that jazz. And I actually spent a lot of time with Dave Abrahams. He was the head of the API, Swift API at Apple. Also worked on the SwiftUI layout engine at Apple before he left. And he now is at Adobe, fortunately. So we spent a lot of time actually. I kind of got VIP customer support from him on the Behance SwiftUI code base. And I learned so much from him actually about how SwiftUI works and what makes sense for doing SwiftUI. So he's a huge advocate for structs before classes, and doing everything with structs. I think I'm not exactly sure what I think about it. I think it has benefit, pros and cons, like everything. I do agree that it probably makes sense to keep things simple by default, and default to a struct. So, for example, if you do use MVVM, and your view model can be a struct or a class, and that's a great question. What it should be, I would probably say default to a struct, and then if you do have a need to make it a class, then switch to a class. I don't think there needs to be like a rule against classes or something like you need to avoid it at all cost, or kind of like think how you can not use it or something like that.
Well, how about something like you have basically one main app view and you use environment object and then use published properties on the environment object.
Yeah.
Can that throw more complexity than should be, or is that still okay? Because I guess the question being is like, what if you have a complex view with children, right? And then you want to pass those properties down to the children. What's kind of the best way? What's the best approach in that case?
Yeah, so that's a really good question, and that's also a pattern I've started to see people use. And again, I'm not saying you should never use it or you should always use it, but with this pattern, you do need to be cautious about how you use it. So it's also similar to how Redux works with React, which is you have a single entity or a single object that is the state of the entire app, and then you pass that either using dependency injection with environment object, or you can literally pass it to your children views from each view. Whichever way you use, basically the problem with that approach is that if you have a single big object that has everything, and all of your views are using it, it doesn't matter if it's environment object or observed object, but just the fact that it's declared in those views. Every time anything changes in that object, or I'm sorry, any of the published properties change in that object, all of your views that use it will be recreated and diffed, and probably their body will be called. And most likely, not all of your views need to be reevaluated for every single thing that changed in the state of your app. And so I know that many people do it, and it's great, and it works fine. But definitely something that I think you need to be aware of if that's the way you go. If you have this one big state bucket, in practice it might be okay, but in theory, or technically, you are kind of like hurting SwiftUI ability to do its thing. You sort of go against the framework in that sense, where you kind of telling the framework like, I don't care about your optimizations. I want the entire view tree to just be recreated every time something changes.
Yeah, there'd be no way of knowing that based on the documentation. So
Yeah.
like,
The
yeah,
best
that's
documentation I
super
got for
helpful.
that, which is again, it's not documentation. Yeah, I think the best performance tips I got about SwiftUI were either tweets from Apple engineers or things that Apple engineers said in Apple's office hours. That's probably that's usually where I get my
Yeah.
tips. So in one of Apple office hours, I think a year ago or almost a year ago, Apple had a series of sessions where they invited basically anyone who wanted to join to a conversation with SwiftUI engineers. They did it for multiple frameworks. I only joined the SwiftUI ones, and it was amazing. It was actually, the SwiftUI team was on a Zoom call, and people just asked questions and they just answered. And so one of the things someone said was, what do you think about something like Redux, where you have a single context or state or whatever you want to call it, object at the top, and then everything it depends on it. And they kind of said, you basically sort of shooting SwiftUI in the foot when you do that, because sure, in some iPhone 14 Pro, with the whatever is the new CPU, it's so strong and it's so fast. It doesn't care. And actually, because of that, when we did the main feed and the new screen in Behance, I use this device. That's my test device.
I can't see it.
Sorry.
iPhone.
I don't know if you can see it, but it's basically the iPhone 6s Plus, which is
nice.
The worst.
I can't even upgrade to 16.
Exactly. I have two of them actually. One with iOS 14 and one with iOS 15. It was not easy to get them on eBay because I wanted to get them sealed to make sure I don't have any bugs from used device. But that's the slowest device we support because our app is iOS 14 and up. And the difference is huge. Running the same code base, the same SwiftUI code base on my personal device, which is a 12 mini, and that test device, which is the 6S Plus. Specifically, the 6S Plus, by the way, is even worse than the 6S because the Plus has more pixels to render.
It's the bigger screen.
Exactly.
Yeah.
With the same CPU. And so
I want to ask, you talked about React or Redux. How does Combine fit into that when you want to manage state? Like when you want to manage the state of something based on the state of other conditions or states, essentially.
Yeah. Okay. I'm going to take a question and answer something else instead.
Okay, go ahead. Yeah.
So basically, Combine is a very interesting framework. When Combine came out, I read the Combine book by Shai Micheli, I think his last name is pronounced.
Yep.
The Ray Renderlich book. And then when Async Await came, the concurrency framework, I also read that book by Ray Renderlich, and we ended up using actually both frameworks in the app, in the new screen, in the new feed screen. And I think both of those frameworks are, and again, then this is open another Pandora box about, is Combine dead? Is Combine alive? Is concurrency still replacing it? Should I even learn Combine? All that. I think it's the same conversation as whenever Apple introduces a new technology, or at least lately when they introduce a new technology, it feels like Apple is saying, we are not here to make the decision for you. We are here to give you the tools to make your own decisions. And I think that's amazing. And again, it's kind of like a shift from what we've seen with UIKit, when UIKit is very opinionated. Apple was saying, you will use delegates and there is no other way to do things, basically. With some APIs, exactly. Yeah, with Objective-C, that's all they gave us. And sometimes they didn't even give us delegates. They said, okay, you're going to use KVO. And That's it. That's your only option, which is even worse than delegate. Now we have
Yeah.
combine, we have concurrency. In SwiftUI, there are so many ways to do the same thing. You can use environment, or you can pass the variables to your child. You can keep things in your view. You can put them in a view model. You can use this redux method of a single state object. You can have a state object for different features. You can do whatever you want. And I think the same goes for Combine. Combine is a great framework. I really like it. It's super confusing to get started with, in my opinion. But it's super strong once you figure out what's going on in there. So yeah, I think it's another great way to architect parts of your app, basically. And again, I don't know if I would say that you should like kind of something like SwiftUI plus Combine is a silver bullet for everything. I don't think that's the case. But there are definitely cases where Combine is amazing, and I mean SwiftUI is using Combine. Binding,
Right.
publish.
That's what I was gonna say.
It's all combined under the hood, and it only means that if you do use Combine, it almost feels like it's meant to happen with SwiftUI. When you can have a huge chain of publisher and of subscriptions, and at the bottom, instead of using the sync, if people didn't use Combine, basically, you map different things and different values, and you change them, and you subscribe, and then all the way at the bottom, you say, okay.
Right.
Now I need to do something with that, not in the Combine framework. And so the way to do that is you use the sync function, and sync, literally like a sink where everything pours into the sink, just gives you the value and do whatever you want with it. And so with SwiftUI, instead of using the sync, you can just assign the value you ended up with to some binding or published property, and it works beautiful.
Well, what I've done is I've gone the other route where I've taken something that you call a method, but rather than calling a method, you use a pass-through subject and send a void, essentially, and then Combine uses that to then change state, as opposed to the other way around, where like sync calls a method. I'm actually taking methods and turning them into subjects and then using a sign at the end. So I love Combine. I think like, to me, like I've started using more async await, and what I've found is async await. And I'm still not super familiar with async stream yet, which supposedly does a lot with what Combine does.
Mm-hmm.
But what I've seen is like async await is just really good when you have multiple processes that are asynchronous that you need to manage, but you don't necessarily need to react to, if you know what I mean.
Yep.
Like that's where async await really is helpful. Whereas Combine to me is more about state management and reacting to state management, and then supplying information or state to SwiftUI. That's the way I've seen it.
Yeah, I think now when I'm thinking about it, I feel like a big difference between Combine and concurrency is that Combine gives you amazing power over what happens with your data, and async await gives you amazing clarity when you try to read your code. When I look at my Combine code,
exactly.
It's sometimes hard to keep track of what's happening, or it takes me a minute to be like, okay, what did I do here? Or when I work on Combine code base, it's a little bit. You need to be very focused on what you're doing. With async await, it's just so clear and so nice, the API, that it's just amazing, and there is just like no questions. It's you just look at the code and it's instantly obvious what's going to happen. And so I guess those are two interesting, kind of like advantages to each framework, where if you need to do something very complicated with your data, maybe use Combine. If you need to do something confusing with your data and you're scared to do it wrong, maybe use concurrency to make sure that it makes sense and easy to reason about. And actually,
right.
A funny thing is, we ended up, so we have this object that's called the feed provider, and it's a huge class with a ton of logic. And in the end, all it provides is a single published computed property, which is called, I think it's called data. And it's an array of projects to show in the feed, in the app. And that class which we slowly, built and added things to it and improved over the last year, is using both combined and concurrency in different places.
Okay.
Actually, in the same pipeline. So we had to do some crazy things to get performance on this horrible device. I just talked about the iPhone 6s Plus, and so to get that to work seamlessly. Probably not 60 frames per second, but maybe 30 frames per second, which is, I guess, not good enough for that device. And so what we do is we fetch items from the backend. We use GraphQL, and then we parse them. But then we also prefetch the images. So the GraphQL response will arrive with URLs for the images of the content of the project. And then we download those images, but those images are pretty heavy. So if we just instantly download all of them, we get out of memory. So we cannot do that. Right. So we download,
especially on a 6S Plus.
Exactly, especially on a 6S Plus. I had a lot of out of memory crashes with that device. And so what we do is we use Combine to limit the number of concurrent tasks that we have for downloading an image, because when we are done downloading that image, we scale it down to 25%, and then on the UI, and we cache that. And then on the UI, we are showing you this like almost blurred image while we are fetching the full resolution image and showing it on top of it. There is some crazy logic to do that, and to do it, we want to do it concurrent on one end, but not get out of memory or choke. We also had an issue where, because we did all of those in parallel, we would choke the CPU, we would choke the threads, and then the main thread couldn't do anything because all the CPU cores were working. So controlling that, controlling how many images we have in memory at once before we cache them, so we don't get out of memory, while we want to keep the order of the items as they came back from the backend, because we don't want to mix the items. If we manage to cache one project earlier than the other project came back, we want them to stay in the same order that the backend ranked them. All that is super complicated logic, and we ended up using both Combine and concurrency, and both end up really useful for us.
I've been using more of the Future publisher. I have like this extension now. I have pretty much in all my projects where I wrap an async await in a Future publisher, because there's nothing like that yet. So that's one way I've constantly had to use both when I want to wrap an async await in a publisher. So 2 more questions. Is that all right?
Yeah, definitely.
Okay, cool. So go back to your 360 talk. You mentioned, we talked about POD. You talked about that, but you also talked about this idea of like internalized views, where you have like a private view within a thing, within a package or app or whatever. And then you use that. Why do you do that? And how is it helpful to the performance of SwiftUI?
Yeah. So this is, it's a very interesting hack. And actually, I remember when I showed it to Dave Abrams, I was sort of expecting him to tell me like, this is not how SwiftUI is supposed to work. You need to think your design. Dave has really strong opinions on API design and stuff like that, which I guess is part of why he got him to where he is, and I help improve our code so much. So I was ready for this feedback basically, and ready to hear his opinions on how we can improve it and change that. But then all he had to say was like, oh, that's pretty interesting. So that was kind of my my approval that my hack is actually as far as I can get is probably that's probably the best approval I can get from official SwiftUI team member. So basically the idea is going back to POD views and memcompare. Like we said, we want our views to be compared using memcompare and not using reflection. But there is no way to tell SwiftUI, hey, can you please use memcompare? Or hey, can you make this a POD or not POD? This is something that the framework decides for you. And so the official API SwiftUI gives us is custom equality. The problem with custom equality, with the double equals function, is that it's another piece of code you need to maintain. It's another thing that can have bugs. And most importantly, it's another thing that you can forget about. And so you might add a few properties, add some state or whatever to your view, create a custom equality. 2 weeks later, either the future you or some other engineer on the team will add a new property. They didn't notice that custom equality at the bottom of the file, and they don't update that function. And now you have a view that is essentially ignoring one of its property when deciding whether it should be updated on the screen or not. And then you have bugs, and then you don't understand what's going on, and then it's not fun, basically. That's the TLDR of that. And so there is an interesting way to kind of avoid using custom equality, but still use the faster memcompare method. And the way to do that is essentially separating your dependencies from the state. And then I need to kind of like take a step back and explain what that means. And so we are used to say state of the view, but state is only part of what the view uses. So SwiftUI view actually has two different things. It has dependencies and it has state. I guess maybe you can call both of them the state because this is the state of the world at that time, and these are the pieces of the state that the view cares about to render itself. But some of them are state in the sense that your view creates them, and SwiftUI retains them specifically for your view. And notice I'm very carefully choosing my words here because I'm trying to avoid saying your view owns the state, because that is not true. Your view never owns the state. And so those are at state and at state object. Those are things that are not passed from above. Those are things that you provide the initializer inside your view, which is also why they should always be private. So the caller doesn't accidentally provide them to you. So they should be private, and you create them. And that's the state of your view. Dependencies are the things that are provided to you, are the things that you get from your parent. Usually just simple let. So a binding is kind of like the challenge here, because if you have a binding, you don't have a way around it, because you have to declare it in an exposed way so the parent can see it. And then there might not be a way to do this hack that I'm going to explain in a second. But if you only have simple let values that you get, that your parent provides, and some state that is private and your parent doesn't even need to know about, if you have that case, then you can split your view. And what you do is you create an internal version of your view. When I use it, I literally just add the word internal. So if I have, something called like project view, then I will make another view called project view internal. And then I will move all the state and state object, and also environment, actually, because an environment object can also be private. Magically, SwiftUI will inject them to your view so they can be private. Your parent doesn't need to know they even exist. So environment object, state, and state object. All of those go into the internal view. In my case, project view internal. And then what's left in the public project view are only the dependencies, only the things that are passed. Sorry, that's my dog. Only the things that are passed from above, from your parent. And then you end up, and then in that public view, all you do is you just create the internal view in your body. That's it, and pass whatever was passed from the parent. So you basically create this weird proxy view, and it gets a little bit confusing. But we can probably link to the talk, and people can see how the code looks like. And what ends up happening when
the idea is that you're streamlining the performance by reducing the things that can change, I guess, so that way the view isn't constantly redrawn when it doesn't need to be.
Exactly.
Right?
Basically, you split your view into two. One is now a POD view, the external one, and the internal one is a big, complex, heavy, whatever non-POD view. Yeah. And then you give a chance to SwiftUI to create the external view, which is now a POD view. Do a simple memcompare. See, the dependencies didn't change. I don't even care what happens in the internal view. I'm not even going to create it. And then the internal view is not even initialized, but is not called. and then you avoid that heavy diffing algorithm, basically.
Right. So last question before we close out. What do you think, if you have like big takeaways or big things people should do when they look in their SwiftUI code base after listening and watching this episode,
Mm-hmm.
what are maybe like some 1 to 3 things that they can do right now to be like, go through their code base and fix as soon as possible?
So I would say probably the first thing is making sure you use property wrappers correctly. And so I say that for 2 reasons. One, I think the API is confusing. I'm not sure, even if I was the SwiftUI team, I don't know if I have an idea how to make it easier to do the right thing. The best thing you can do about an API is make it easy to do the right thing. I don't know how to do that with the current API. But the fact of the day is that the property wrappers API with SwiftUI is confusing. And then I'm not surprised people are confused by it. And almost every single time I look at someone else's SwiftUI code, including my own many times, I think literally yesterday I fixed the bug because I used the wrong property wrapper. There are issues with the property wrappers and how people declare state and dependencies in their views. Either using state instead of state object, either using state object instead of observed object, using binding when you don't need it, which is the binding one is a big one. People think that they have to make it binding to make the view update. That's wrong. You can make it a simple let, just a let property, your view will still be updated. Binding is only if you want to change that property. So there are so many ways you can do it wrong and have the app still run, and you might initially think, oh, this works. Only later you find out that you have weird bugs or something weird is happening, or performance is bad. And so I would say that the first thing to do is make sure you use property wrappers correctly in the right way. And in terms of resources for that, first of all, there is a really good WWDC talk. I think it's called Data Essentials in SwiftUI. I think it should be required, almost like you have to pass a test to get a driver license. I think if you want to use SwiftUI, you have to watch that talk. And then the other resource is actually a Twitter thread I posted a couple days ago that essentially goes through all of that and shows, this is the right way to use property wrappers. So I would say this is kind of like the lowest hanging fruit, at least based on what I've seen, both in my own code base in SwiftUI and others. And then the other thing I would say is remembering that SwiftUI is just a UI framework. It's not a framework for the entire app. And so when people think, how do I build my app with SwiftUI? No, it's how you build the UI with SwiftUI. Your app can still be built however you want. And it's a case by case. And I don't think, don't try to find the one true way to do it. Do what works best for your app. And yeah, I think that's about it.
Aviel, thank you so much for coming on. I really appreciate it. This has been super, super helpful to me, and I hope it's as helpful to the audience. Where can people find you online?
You can find me online on Twitter mostly. I'm pretty sure my handle, I'm Aviel GR, AVIELGR. That's probably the main place to find me.
People can find me on Twitter at LeoGDion. My company is Bright Digit. Please take some time to post a review on Apple Podcasts, Google, or Spotify, wherever you're listening to. If you're watching this on YouTube, please like and subscribe. Really appreciate it. Thank you so much for joining us, and I look forward to talking to you again. Bye, everyone.
Bye-bye. This was really fun. Thank you.